We're given that this square has side lengths x, and then we're told that t is the midpoint of QR. Now that immediately means that this length here is going to be a half x. And we want to know what the length of TU is. Now we have some other information. We've got a right angle here, and then this is the diagonal is going to split the 90 degrees into two. So this is 45, and this is also 45. So what I'm left with is an isosceles right angle triangle. And there's really, I mean, it's worth knowing this. To go from here to these two sides, you basically just divide through by root 2. So it's going to be x over 2 root 2. And that's our answer. Now, if you don't know that, okay, we can derive it. It's not a big deal. It's just, I would say it's worth knowing. I'm just going to show you where it comes from. So let's just imagine for a moment I have y and y here. Then I would do this one here would be y squared plus y squared square rooted, which is the square root of 2y squared, which is root 2y. So what you see when I'm going from this right-angled isosceles triangle to the hypotenuse, I just times it by root 2. And the consequence is that if I've got the hypotenuse, I just divide by root 2. And that is why I knew to just do that here. So if you know that result and you've got the hypotenuse, yeah, you just do it straight away. Otherwise, okay, again, a longer way would be to say, okay, I'm going to call this z and z. So then z squared plus z squared, that's 2z squared, is going to equal a half x all squared, which will become a quarter x squared. That means z squared will be 1 over 8 x squared. And now we can square root. So it will be x over the square root of 8. And you can simplify that to x over 2 root 2. So different ways to do it. I would say this is worth learning if you're doing lots of these sorts of competitions. You can just like get there really quickly.